So in this question, we have an object traveling down a ramp at constant acceleration. So that means we have the components of gravity Fg perpendicular and force normal being equal and opposite to each other. It's that constant acceleration. So that means the net force is not zero. So if it's traveling down like so, we have our force of gravity parallel and our force of friction, yielding a net force in the positive direction. And that is remaining at a constant. The net force is constant, so therefore the acceleration will be constant. So which would be true about the motion? The force of friction is less than the gravity parallel. That looks like that's true. If the object increased mass, the object's acceleration would change. Now, at first glance, you might picture that it would slow down. But if we look at the force of friction, which is mu Fn, and Fn is mg cosine theta, what we can see is increasing the mass will increase the friction. But if we look at the force of gravity parallel, that is mg sine theta. So if we increase the mass, we are also increasing Fg parallel. And if we double the mass, we double the force of friction. We double the mass, we double the force of gravity parallel. So increasing the mass will actually have no effect on the acceleration because the forces will increase in proportion to each other. And the normal force, which we said is equal to Fg perpendicular, which is mg cosine theta, well, the normal force would remain the same as false. We know increasing the mass will increase the force normal. And the force of friction acts in the same direction that the object travels. Well, the force of friction is not down the inclined plane, it's up the inclined plane, so that is false as well.